Hello class, today we will be talking about angles and how to identify them and how to measure them. This is going to be a first part of a two-part series. Parts of an angle. These are just what makes up an angle. There's two real main parts, the sides of an angle and the vertex of an angle. The vertex is a point, the side is going to be some one-dimensional figure, a line, a ray, a segment, something of that sort. When we combine those two segments and rays or lines and rays or whatever shapes they end up being, it will be a two-dimensional shape like this. This right here is an angle. These two rays, ray BC and ray BA, form the sides. Point B forms the vertex. This is an angle. In specific, you could think about this small area right here being an angle, but it's really just going to end up being this whole shape is an angle. This whole shape is an angle. When we name it, we're going to name it by its vertex. So I could call this here angle B. I could write out the word angle, or I could use the shortcut angle B. This here would be a name that I could call it angle B. Note that I drew the shape, an angle, and B. Angles will look something like this. They might be rotated, they might be flipped over, but they will have a corner called a vertex. If it was hard to tell which angle I was talking about, for instance, if I would look at this right one over here, and I said angle E, do I mean this part, ray EF and ray EG with vertex E? So this part, am I talking about that angle? Or am I talking about ray ED and ray EF with the vertex being E, and I'm talking about this bigger angle right here? Well, whenever it's in doubt, you have to name it with all 3 points. A point on a side, followed by the vertex, followed by the other point on a side. This angle over here would be called angle FED. This is how I could write it. Angle FED. And that would be talking about this larger angle. This angle over here, angle FEG, that would be the smaller angle, and that's how I would name it. So in this case, I couldn't say angle E because you wouldn't know which angle I'm talking about. But angle FED and angle FEG, you should know exactly what I'm talking about. Please note, both of these have a different name. This angle right here could be called angle DEF, reversing the order. E has to be the middle letter. There is a third angle here, and that's called a straight angle. It's 180 degrees or a straight line. That would be angle DEG. That would be the big angle that is the combination of the two. Ray ED and ray EG have the vertex E. It's a straight angle, 180 degrees. This angle right here, angle FEG, is an acute angle. It's less than 90 degrees. An angle FED is going to be obtuse. It's greater than 90 degrees, but less than 180. If it was exactly 90 degrees, we call that a right angle, and it's going to look like as if it's like an intersection. It would go straight up and down, where this line would go horizontal, and there would be an angle here that would be a right angle. You could also think of it as a corner of a square. That's a right angle. Name all the angles in the figure below. These are all the angles in the picture below. Note, these three for the triangle, angle F, angle E, and angle G, are all by themselves. There's no question when I talk about angle F, I'm talking about the top of the triangle, or angle E, or angle G. There's no question which corner I'm talking about. But when I talk about angle B, you wouldn't know what I'm saying. So I have to be specific. Angle ABC is the obtuse angle. It's the larger angle. Angle CBD is a smaller angle, and angle ABD is a straight angle. For the last part here, we are going to be learning about measuring with a protractor. When we talk about the measure of an angle, we're talking about its size. Before, when I said acute, right, obtuse, and a straight angle, those all have a measurement. We actually have a way to say this is how large the angle actually is. For my purposes, I'm using this. For your purposes, you would use something like this. The way you would be able to know how to read this is you would start at this hole in the protractor, and you would line up one side of the angle with the black line going through the hole. Then you would measure with the other side what number it reads. If it's less than a right angle, corner of a square, it's going to be the smaller number. If it's larger than a right angle, it's going to be the larger number. Postulates. These are what allow me to do all of geometry. Remember, they're the foundation of all rules. A postulate is a rule that is accepted without proof. You can do what I'm about to show you. I can't prove to you why. It's just how we define being able to measure an angle. Alright, with these 4 angles here, there is another way to name them. Angle 2 here, if there's a number inside the angle without the degree symbol. Remember, the degree symbol is just a little number that you put up here. It looks like a 0. That would be a degree. It's not measuring the angle or not labeling the angle. This is another way you might commonly see in your book. Angle 2, angle 1. I can call this one angle E. I can call this one over here angle B. 2 other names for this one would be angle ABC and angle CBA. Written as such. Over here, angle 1's good enough. Now, to measure with a protractor, you always line up the point designated with the vertex. In this case, here's the point. That's designated right there at the bottom. For you, it would be the hole in the protractor. For me, it's the very bottom of my protractor. Then, you line up the bottom with one side. It doesn't matter which side. Then the last thing you do is you read off the number that the line goes through. So right here, it goes 1 notch shy of 130. Each notch on here is 1 degree. Seeing it's greater than 90 degrees, it's going to be the larger number. So 1 less than 130 is 129. 0 all the way to 129 is what this has. Angle 1 has a measure of 129 degrees. Now, if I write angle 1 equals, that's wrong. Because angle is a shape. It's not a number. Numbers are for equal signs. If it's not a number, it can't be in an equation. When I put an m in front of it though, now that's a number. Measure of angle 1 is just a number. And there I go. I've measured angle 1. It's 129 degrees. Angle 2 over here. Vertex on the point, bottom lined up, and it goes just shy of 90. In fact, it looks like it's halfway between 88 and 89. So I'm going to go with 88.5. And that's angle 2, remember. So if I'm going to report my answer, I would have to report it as such. Measurement of angle 2 equals 88.5 degrees. That's how I have it written. Corner right here along this side. Now, it's just shy, or actually it looks like it's dead on for 40. Or maybe it's 140. Well, because this angle is smaller than 90, it would have to be the smaller number, 40. Again, I'm not going to say angle CBA. I'm actually going to say measure of angle. And I don't see a reason not to call it B. So let's call it measure of angle B equals 40 degrees. The last one, angle E over here. When I match it up here, you'll see that it's a straight line. In this rare case, you would actually just report measure of angle E as 180 degrees. So measure of angle E is 180 degrees. At this point, you should be able to name angles, find their measure using a protractor, and understand why we use an M when we report our answer for measuring an angle, and why that's distinctly different than just using angle 1 or angle 2. Have a good day.